Question 1. The lengths of 3 sides of a triangle are in the ratio 3 to 5 to 7. What fraction of the perimeter is the longest side of the triangle? So if we need to start by writing this ratio as fractions. So the denominator of a fraction is the total number of equal parts. So let's find out how many equal parts we have in total. So 3 plus 5 plus 7. 3 plus 5 plus 7, we have 15 equal parts in total. We want the fraction of the longest side of the triangle. So if we were to write each part of this ratio or each section of this ratio as a fraction, we would have 3 out of 15 to 5 out of 15 to 7 out of 15. Okay? Now the longest side is going to have the most number of parts. So the longest side of this triangle is going to be the 7 because 7 is bigger than 3 and 5. So the fraction of the perimeter that is the longest side of this triangle would be 7 out of 15. Part B. The perimeter of this triangle is 60 centimetres. Find the length of each of the 3 sides of the triangle. So we need to share our ratio 3 to 5 to 7 that they gave us at the start. So we're sharing 60 into that ratio 3 to 5 to 7. So we know our total number of parts is 15. We worked that out in part A. Remember, part A sometimes helps us. So we're going to start by doing 60 divided by 15. So that gives us an answer of 4. So one part of this ratio is worth 4. We've got a ratio of 3 to 5 to 7. So we're going to multiply each of those sections of the ratio by 4. So those 3 parts multiplied by 4 is 12. The 5 parts multiplied by 4 is 20. And the 7 parts multiplied by 4 is 28. We have to remember to do it to each part of the ratio. So the length of each side of this triangle is 12 centimetres, 20 centimetres and 28 centimetres. So 12, 20 and 28. Question 2. The bearing of Q from P is 140 degrees. Find the bearing of P from Q. So when we're dealing with bearings, we need to make sure we're working in 3 figures. That one's given in 3 figures, 140, so we're good to go to start off with. I'm going to sketch a little diagram here just to get my head round what it is I'm looking for. So if I was getting the bearing of Q from P, I'd be starting at point P. I would have a north line there because I measure clockwise from north with the bearings, and then 140 degrees. I'm not drawing this completely accurately, guys, but it would definitely be over 90 degrees, wouldn't it? So that would be 140 degrees from P to Q. Okay, so that's what we would have measured for the bearing of Q from P in a clockwise direction. We want to find the bearing of P from Q. So we want the bearing of P from Q. So we would start at Q. So we would need a north line at Q. And then we would measure clockwise from Q to P to get our bearing. So we don't need to use a protractor here, don't worry. But what we are going to use is angle facts. So these 2 north lines here are parallel because north lines will always point north. They will always point in the same direction, and they will never meet. So if we've got these 2 parallel lines here, if we deal with this shape and these 2 angles inside those parallel lines, those are co-interior angles. So 140 degrees plus this angle should add to 180. So 180 subtract 140 is going to leave us with 40 degrees. So that angle there is 40 degrees, which is helpful to us because we want this angle clockwise from that north line all the way round to the line that connects P to Q. Now angles around a point in a full circle add to 360. So we're going to subtract that 40 degrees from 360 and that will tell us what this bearing that we're looking for is. So 360 subtract 40 is 320. So the bearing of P from Q is 320 degrees. Question 3. The nth term of a sequence is given by 2n add 9. Part A, work out the difference between consecutive terms. So when we're working with the nth term, the difference between consecutive terms, so what we do to get from one term to another, is always indicated by that value in front of the n. Okay, so n is its position in the sequence. So term 1 would be n would be 1, term 2 n would be 2, but the number in front tells you what's happening to get from one term to the next, that term to term rule. So the difference between consecutive terms is going to be 2. So we're going to write our difference is 2. Part B, I. Solve 2n add 9 is less than 99. So this is an inequality. We're going to solve it like we would solve a normal two-step equation, but instead of writing an equal sign, we need to keep that symbol there. So I'm aiming to isolate n. So the first thing I'm going to do is I'm going to subtract 9, because that will eliminate my positive 9 here. So when I subtract 9 from the left-hand side, I eliminate my positive 9. I'm just left with 2n. I need to keep my less than symbol. And then when I subtract 9 from the right-hand side, making sure I balance the equation, 99 subtract 9 is 90. Now remember, when I'm solving, I'm aiming to isolate that variable. So I'm aiming to isolate n. So I want this to be n is less than something. So I need to eliminate the 2 that's in front of the n. Well, 2n is 2 multiplied by n. So the inverse of multiplying by 2 would be to divide by 2. So when I divide the left-hand side by 2, I'm left with n. So I've isolated that variable. When I divide the right-hand side by 2, 90 divided by 2 is 45. This whole thing here is your answer, so make sure that is nice and clear to the examiner, because there's no answer line here to put it on separately. It's really important that you keep that inequality symbol there, guys. If you put an equals, you're not going to get the full marks. B, part 2. Write down the number of terms in this sequence that are less than 99. Okay. So the number of terms in this sequence that are less than 99. So again, we're going to use this part here to help us. So we know that when the solution to this equation is less than 99, n has a value that is less than 45. Now remember what I said. N is the term number. So the first term, n would be 1. The second term, n would be 2. The 50th term, n would be 50. So this is saying to get an answer, a solution of less than 99, n has got to be less than 45. So the number of terms that this sequence has that are less than 45 is the whole number that's just before 45, that integer that's just before 45. So 44 terms have a solution of less than 99. Question 4. James has been on holiday to the USA and is flying home to the UK. The price of a gift in a shop at the airport is $65. The price of the same gift online is €60, including delivery. On the day of his flight, the exchange rates were as follows. So 80 pence is equal to $1 and £1 is equal to 1.2 euros. Is it cheaper to buy the gift at the airport or online? So we're going to have to tick one of these boxes, but we need to show how we decide. So I'm not going to tick anything here, just on instinct. I'm going to do some working out. So what we need to do here is we need to either convert the dollars to euros to compare it, or convert the euros to dollars and then compare it. So we're comparing the shop in the airport compared to online with delivery included. So I'm going to convert from dollars to pounds to start off with. So I'm going to do myself a little proportion table. So this is dollars and this is pounds. So I know that $1 is 0.8 pounds or 80 pence. Okay. We're working with $65. So I've scaled up here. I've multiplied by 65. So I'm going to do the same to the other side. I'm going to do 65 times 0.8, okay? So 0.8 times 65. Well, I'm going to multiply that by 10. So I'm doing 8 times 65 because that's just a little bit easier for my brain. So 65 times 8, well, 8 times 5 is 40. 8 times 6 is 48. So that's 520 here. But if I want the answer to 0.8 times by 65, I've got to reverse. I've got to undo that times by 10. So I'm going to divide by 10. So 0.8 times 65 is 52. So that gift is £52 in the airport. Okay? So now what I'm going to do is I'm going to convert that £52 into euros, and then I can compare it with the online option. So I'm going to do myself another little proportion table so I don't get confused using the same one. So here we've got £1. So £1 is equal to 1.2 euros. Okay, we've got £52. So what I've done here is I've scaled up, I've multiplied by 52. So I'm going to do the same on the other side. So 1.2 times 52. Again, I'm going to multiply that by 10 so I don't have to work initially with decimals. So 12 times 52. 2 times 2 is 4. 2 times 1 is 2. Placeholder 0 because I'm moving into the tens column. 5 times 2 is 10. Carry the 1. 5 times 1 is 5. Add the 1 is 6. So that's 624. But I need to reverse the times 10, so I'm going to have to divide by 10. So that's 62.4. So it's 62.4 euros. Remember, this is still at the airport, guys. Okay? So, at the airport, it's 62.4 euros. Online, it's 60 euros, including delivery. We need to know which one is cheaper. Well, that 60 euros is less than 62.4 euros, isn't it? So I can say that it's cheaper online than it is at the airport. Question 5. So we've got a diagram here and it tells us the diagram shows a quadrilateral. So we've got a four-sided shape and then we've got some exterior angles labelled as well. The fact that it's a quadrilateral could be important, so let's pay particular note to that. Use algebra to find the size of the exterior angle y. So we're aiming to find this angle here, and they want us to use algebra, which is useful because we've got some algebra there on the diagram, haven't we? We've got some numerical angles, but we've also got some angles that involve the variable x. So this is a quadrilateral. So what do we know about angles inside a quadrilateral? Well, angles in a quadrilateral sum to 360 degrees. So all of these angles here should add to 360 degrees. So I'm going to start by forming an equation for the sum of those angles because that's something I can work with. So we have 60 degrees plus x plus 75 degrees plus 85 degrees plus x plus 70 degrees, and they should all equal 360 degrees. So I'm just going to simplify this a little bit more. So we don't need those brackets. Those brackets are just to safeguard us if we have some negative values or variables in there. So if they're confusing to you, at this point we don't need them. So we're going to collect like terms. So we're going to do x plus x, so we have 2x, and then we're going to do 60 plus 75 plus 85 plus 70. So 60 plus 75 is 135. Well, I'm just going to do this. Why am I going to make my brain hurt, guys? Okay, so 10, 8, 16, 23, 29. Okay, good. There you go. So they add to 290. So I can write an equation. 2x add 290 must be equal to 360. So they want us to use algebra to find the size of this angle here. Great. If I know this angle, I can work out that exterior angle y, but I need to figure out what x is first. So I've formed an equation and I'm now going to solve it for x. So I'm aiming to isolate the variable x. So the first thing I'm going to do is I'm going to subtract 290 from the left hand side because that will eliminate my 290 there. Subtracting is the inverse of adding. But then when I do the same to the other side, 360 subtract 290 leaves me with 70. When we're solving, we're aiming to isolate the variable. So I'm aiming to get x on its own. So I want it to be x equals 2x is 2 multiplied by x. The inverse of multiplying by 2 would be to divide by 2. So 2x divided by 2 gives me x. 70 divided by 2 gives me 35. So x in this diagram has a value of 35 degrees. I can now use that information to find this angle here because this is the one that's got a relationship with the angle that I'm looking for. So x plus 70, well, when x is 35, 35 plus 70 is 105 degrees. So this angle numerically is 105 degrees. Now this is where we're going to use another angle fact. These two angles are related because they are on a straight line. Angles on a straight line they sum to 180 degrees. So if I do 180 subtract that 105, so y equals 180 subtract 105, which is 75 degrees. So I'm going to pop 75 degrees on my answer line. Okay, 6a, Sam cycled south for 16 kilometres. He then turned and cycled east. When he stopped for a rest, the shortest distance back to his starting point was 20 kilometres. Calculate how many kilometres Sam cycled when travelling east. So I'm going to draw myself a diagram again here, guys, because drawing diagrams helps me visualise what's happening because that's just a lot of words for me. Okay, so we've got our north arrow, so that's the direction of north. So Sam cycled south for 16 kilometres. So I'm not bothered about the accuracy of my line. I'm not working with a scale. But if he travelled south, he went straight down here. So if that was his starting point, straight down for 16 kilometres. He then turned and cycled east. Okay, so north, south, east, west. So he's turned and cycled east. So he's gone in that direction there. So we've gone that way for a certain amount of time, a certain distance, we don't know. Then he's stopping for a rest. So he's stopped here for a rest. And then he's taken the shortest distance back to his starting point. So this is his starting point. This is where he stopped. So the shortest distance back would be to travel the diagonal. Okay. So he's done the shortest distance back, which was 20 kilometres. So this length would be 20 kilometres. And by drawing a diagram, I've given myself a right angle triangle. Okay. They want us to calculate how many kilometres he cycled travelling east. So they want us to calculate this side of this right angle triangle. So I'm going to label that X. That is what we're looking for. Now there's two things we can work with right angle triangles. There's Pythagoras' theorem and there's trigonometry. Well, I've got two sides and I'm looking for the third side. So I'm going to use Pythagoras' theorem, which tells us that a squared plus b squared equals c squared. A and b being the shorter side. So let's do these two. So a squared plus b squared must be equal to c squared. So I'm going to substitute what I know in my diagram. Let's do that a, let's do that b. C always has to be the hypotenuse. Okay, so let's substitute what we have in. So 16 as a, so 16 squared plus x squared, because we don't know how far he travelled east yet, is equal to 20 squared. Well, 16 squared is 256 and 20 squared is 400. So now I'm going to solve this 4x. So remember, we're isolating the variable x. So the first thing I'm going to do is I'm going to subtract 256. That eliminates the 256 there, leaves me with x squared on the left hand side. And then when I subtract 256 from 400, I'm going to get 144. We're aiming for x equals. So there's another step here. This is x squared. The inverse of squaring is to square root. So we're going to square root both sides. So the square root of x squared gives me x. The square root of 144 gives me 12, because 12 times 12 is 144. So I know now that x equals 12. So that is the solution. He travelled 12 kilometres east. Part B. So Sam cycled the 20 kilometres back to his starting point at a constant speed of 25 kilometres per hour. How many minutes did this take? So we've got his speed, we've got his distance, we're looking for his time. So we can do speed, distance and time as our formula triangle. But what I'm going to do here is I'm going to rewrite this with my values in. So speed I know is 25, distance I know is 20, time is what I'm looking for. So 20 divided by 25. So the time taken is 20 divided by 25. Now I've written that as a fraction because what I want to do is get this time in minutes. But when I'm working it out in this way, currently it's 20 out of 25 hours. Okay, I'm going to scale that up. So I'm going to multiply by 4 to make it a fraction out of 100. Do the same to the top. So 80 out of 100 I know is 0.8 as a decimal. That's why I scaled it up to 100 to work with something that I was comfortable with. So this is 0.8 hours. We want minutes. So we're going to have to do 0.8 times 60. Okay. So I'm going to multiply this by 10 so that I'm working with 8 times 60. So 8 times 6 is 48. So it must be 480. But then I need to reverse that multiplied by 10. So I'm going to divide by 10. So that is 48. So it's 48 minutes it took him. And I'm making that nice and clear for the examiner because I ran out of space there. Question 7a. So we have a diagram here. It's a graph and we've got two linear graphs plotted there. So two straight line graphs. I'm just going to move this up a little bit. It asks us to use the diagram to solve the following simultaneous equations. So we have the simultaneous equation 3y minus 3x equals 2. Well, they've plotted that line for us there, look guys. Very helpful of them. We've also got a simultaneous equation of y plus 2x equals 3. That's the other line that they've drawn for us. Also very helpful. So I don't need to plot anything, but I do need to find my solution and I need to give my answer correct to one decimal place. Okay, so the solution to these simultaneous equations when we graph them is this point of intersection. So the solution is where they intersect. And what I need to do is I need to read off an x value and a y value. So I'm going to grab a ruler and a pencil just in case I make mistakes when I'm doing this and I don't want to mess up my graph too much. So this is the point of intersection here. So I'm going to do my ruler down to the x-axis. So it cuts about there. So I'm looking at my scale from 0 to 1. There's 10. So it must be 0.1, 0.2, 0.3. So that's roughly 0.8. So we're going to say x is 0.8. And then I'm going to do the same. From that point of intersection, I'm going to read across to the y-axis. Again, the scale from 1 to 2, there's 10 small boxes, so it's in 0.1s. So that's 1.1, 1.2, 1.3, 1.4. So I'm going to do 1.4. I didn't write them straight on my answer line because I wanted to check that I was getting them to one decimal place. They are to one decimal place, so we're going to say that x is 0.8. and y is approximately 1.4. 7b. The diagram shows the curve y equals x squared, add 2x, subtract 8. So that's this curve here. Part 1, write down the y-intercept of the curve. So the y-intercept is where a graph crosses the y-axis, so where it intercepts the y-axis. So we can see clearly that the curve intercepts the y-axis here at -8, so we're going to write -8 there as our y-intercept. 7b part 2, find the coordinates of the turning point of the curve. So the turning point of the curve is the point at which the curve starts to come back on itself, so it starts to become symmetrical. So it's a point of symmetry, and you could imagine that there would be a line down the middle there that cuts through that point on the curve. Now sometimes we can read that information from a graph. We can go halfway between our x-intercepts, our roots, and then we can read off our y coordinate. However, this scale here is going to be difficult to read from, so I'm going to do this algebraically. I'm going to complete the square. So I'm completing the square for x squared plus 2x subtract 8, because this is my quadratic equation that's been plotted. When we complete the square, just write that there, we want it in the form x plus a all squared subtract b. Okay, the plus and the subtract can change depending on the values. So the a is half of the x coefficient. So inside this squared bracket, I'm going to have x plus 1 all squared, because the a is always half of the coefficient of the x. Half of +2 is +1. I then need to square that value, because this is what completes the square, and subtract it. So 1 squared is 1, so I need to subtract 1. But I've also got to remember about this subtract 8 that's part of the equation. I've got to balance everything out. Now I'm going to simplify this. So x plus 1 all squared, -1 subtract 8 gets more negative, becomes -9. Now once I've completed the square here, I can read off the coordinates of the turning point. So the x coordinate is the opposite of what's inside the bracket. So the opposite of +1 is -1. So the x coordinate of the turning point is -1, and if we look at that graph, that would make sense, because -1 is central between those two x-intercepts that we can see on the graph there, and we want it to be that line of symmetry. And then the y-intercept is exactly what's on the outside of the bracket, so the y-intercept is -9, and if we just look at our graph, that does make sense to us, because the turning point would be roughly here. So that would be around -9. We did it algebraically though to be safe, because we can't really be accurate with that scale. Okay, part 3. Use the diagram to solve x squared add 2x subtract 8 equals 0. So I'm just going to check that we are solving here the same equation, because sometimes there'll be slight changes, which means you have an extra step or two to do. But x squared add 2x subtract 8, x squared add 2x subtract 8, they match. So we're working directly with this diagram here, and we're solving this equation. So we want the roots, we want the solutions, we want those x-intercepts. And I mentioned those for this part here when we were looking at completing the square. So where the curve cuts the x-axis, where it intercepts the x-axis, those are the solutions to this equation. So we have x equals -4, or x can equal +2. Remember, we can get two solutions for a quadratic, two different solutions or a repeated solution. So x is -4 or x is +2. Question 8. The surface area of the Earth is 5.101 multiplied by 10 to the power of 8 kilometres squared. So obviously the surface area of the Earth would be a big number because the planet is huge. So they've written it in standard form, because standard form is really useful for writing really big or really small numbers. And then it tells us that the Earth's oceans are 70.9% of this surface area. And then it says estimate the surface area of the Earth's oceans and give your answer in standard form. So asking for an answer in standard form tells me potentially we're going to be dealing with some really big or really small numbers, but we're estimating. So what we're going to do is we're going to round the values we've been given to one significant figure. to make our lives a little bit easier and to help us estimate. So 5.101 multiplied by 10 to the power of 8, I am going to round to 5 multiplied by 10 to the power of 8, because 5.101 to one significant figure would be 5. Okay, and that's a much nicer value to deal with. I'm also going to round 70.9%. Okay, so 70.9%, I'm going to round that to 70%. One significant figure. So 70 is the first significant figure. That 0 doesn't change it. So don't be tempted to round it to 71, because then you're dealing with another number that's potentially a little bit trickier to work with. Okay, so this is the surface area of the Earth. This is the percentage of oceans, the percentage of the surface area that the oceans take up on Earth. So we are going to find 70% of 5 multiplied by 10 to the power of 8. Okay? So what we can do is, I've got 5 times 10 to the power of 8. First thing I'm going to do is I'm going to divide by 100. Okay? Because I'm working in percentages. So if I do a little proportion table, will probably be easier for you to see this in. So this is 100% of the Earth's surface area, okay? We're wanting to find 70%. So if I scale down, if I divide by 100, that will tell me 1%. So I'm going to divide by 100 on this side, but what I need to remember is dividing by 100 is actually the same as dividing by 10 squared, okay? So when I divide by 10 squared, this becomes 5 times 10 to the power of 6, because 10 to the power of 8 divided by 10 to the power of 2, law of division, we subtract the powers. So 1% of the Earth's surface area is 5 times 10 to the power of 6. I want 70%. Okay, so now I'm going to scale up. I'm going to multiply by 70 to get to 70%. Remember, this is my percentages column. So I'm going to multiply by 70, which is the same as multiplying by 7 times 10. So we've got 5 times 7 times 10 times 10 to the power of 6. Well, 5 times 7 is 35. 10 times 10 to the power of 6. If we add the powers, because we want to keep in standard form here, remember, the law of multiplication, we've got a power of 1 there, so it's 1 plus 6, 10 to the power of 7. Now we want our answer in standard form, so let's check. If our answer's in standard form, that first number must be between 1 and 10. 35 is definitely bigger than 10, so I need to make it a number between 1 and 10 using powers of 10. So if I divide by 10, that would make it 3.5. But because I've divided by 10, to get it back into its original number, if I was to convert it from standard form to a normal number, I'm going to have to multiply it by another 10. So then I have to increase my power. Okay, so my estimate of the surface area of the Earth's oceans, which are 70% of its total surface area, is 3.5 times 10 to the power of 8. Question 9. So we've got a spinner here, and the parts of the spinner are labelled with words that give us a colour. The diagram shows a fair spinner, so that's useful to know. Eve spins the spinner twice. What is the probability that the spinner lands on red both times? So we need to find the probability that the spinner lands on red to start off with. So the probability that we land on a red, well, there are 1, 2, 3, 4, 5, 6, 7, 8 sections in total. And out of those 8, we have 2 of them that are red. So the probability that the spinner lands on red is 2/8, which we can simplify to 1/4, because if we're going to calculate with it, the simpler the better, because we're dealing with lower numbers. So if the probability the spinner lands on red is 1/4 and Eve spins it twice, it's going to be the probability of red multiplied by the probability of red. So it's red and red. So we know the probability of red is 1/4. So 1/4 multiplied by 1/4. When we're multiplying fractions, we multiply the numerators and the denominators, that becomes 1 over 16. So that is our probability that the spinner lands on red both times that Eve spins it. Question 10. In an athletics club, 20 of the female athletes have a mean height of 170 centimetres. 30 of the male athletes have a mean height of 180 centimetres. What is the mean height of these 50 athletes? So what's the mean heights of all of these combined? Now, it's not as simple as just adding those two means together, okay? It doesn't work that way. So we're going to have to reverse both of those mean calculations and take it from there. So we want to get the total height for females. So the total height for females would be the mean multiplied by 20, because what we would have done to calculate this was add them all together and then divide by how many we have. So to reverse that, we're going to multiply by 20. So 170 multiplied by 20. So 17 times 2 is 34. So the total height of the females is 3,400 centimetres. Okay. We also need the total height of the males. So we're going to reverse their mean calculation. So that would be 180 multiplied by 30. 3 times 18, well, that's 54. So it's 5,400 centimetres in total for the males. So now that we have their total heights, we're going to find the total height of all 50 people, because we've got 20 females, 20 males. So total height of all is going to be 3,400 plus 5,400, which is 8,800 centimetres. So that's the total height. There are 50 people in total. We're wanting the mean of those 50. So we're doing 8,800 divided by 50. So 8,800 divided by 50. Now I'm going to divide the top and the bottom by 10. So now I'm doing 880 divided by 5. You can do whatever calculation method works for you. This just works better for my brain, knowing that I can check it out as a fraction first, simplify it as far as I can, and then move it into a division calculation. So 5 into 8 is 1, remainder 3. 5 into 38 is 7, remainder 3. And 5 into 30 is 6. So the mean height of these 150 athletes is 176 centimetres. Part B. A boat crew has 8 rowers and a cox who steers. The heights in centimetres of the 9 people in the crew are as follows. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 heights of these people given here. The mean of these heights is 190 centimetres. Explain why the mean is not the best average to use for this data set. So what I'm going to look at and see is, do they all follow the same trend really? Because the mean is quite fickle. It can be affected by any extreme values. So if there's anyone that's a lot shorter than the others or a lot taller than the others, that can affect the mean. So it's not always the best average to work with. So I'm going to look at this, and so we've got 193, 188, 200, 198, 203, 201. So all of these are quite big heights, but then 150 stands out for me, because 150 is a lot smaller than all of these heights. So I'm going to put that the mean is affected by, let's call them extreme values, outliers maybe, you might have heard that word. And the reason why I'm saying that is because 150 is much smaller than the others. And that's the explanation I'm going to give. So the mean's affected by outlier values, by extreme values, and 150 is much smaller. So that's going to sway the mean. Question 11. The table shows some information about the cost per person to take a boat across the river. So adults in pounds is A, children in pounds is C. So the Jones family, so they've got 4 adults and 1 child, pay £9.50 to take the boat. The Patel family have 5 adults and 2 children, and they pay £13 to take the boat. Now the Lee family has 3 adults and 2 children. How much does the Lee family pay to take the boat? And you must use an algebraic method and show all your working. So we can't use trial and error here, guys. They've told us specifically to use an algebraic method. So what they've given us is the combination of adults and children for 2 families and how much it cost. So I'm going to form 2 equations, okay? 2 simultaneous equations, one for the Jones family and one for the Patel family. So for the Jones family, we've got 4 adults. Well, they say that adults is A. So we have 4A plus 1 child. So plus 1C. You can write the 1 in front of C if you want to. It doesn't make any difference. But they pay a total of £9.50. And then the Patel family have 5 adults. They have 5A plus 2 children. So 2C. And they pay £13 in total. So now we have 2 simultaneous equations, and the reason why we can treat them as simultaneous equations is because the price that the adults pay and the price that the children pay will be the same for the both families. It's a standard rate. So A and C values will be the same, so those equations are simultaneous equations. So what I need to do now is solve them. So to solve them, I'm going to make one of the variables match. So I'm going to label these equation 1 and 2. I'm going to multiply equation 1 by 2. Because when I multiply equation 1 by 2, I'm going to get 2c, which means it will match the 2c here on this equation. So when I multiply this equation by 2, everything gets multiplied by 2. So 4a multiplied by 2 is 8a, plus c multiplied by 2 is plus 2c, and then it equals £9.50 multiplied by 2, which is £19. Okay, I'm keeping equation 2 as it is because I was aiming to get a set of variables matching either A's or C's, and I've managed to match the C's. It doesn't matter if the signs don't match, it's the coefficient that's important. So now I'm going to solve these simultaneous equations. So these simultaneous equations, because I've changed this one to make it work for us. So I'm going to look. So I've got plus 2c plus 2c. So I'm working on eliminating a variable. So if I want to eliminate c, the variable that I've made have the same coefficient, I'm going to have to subtract these equations, because 2c subtract 2c would eliminate it. So when I subtract these equations, I'm just going to treat it like a column subtraction, just to organise my working. So 8a subtract 5a is 3a, 2c subtract 2c eliminates my c variable, which is what I wanted, and then 19 subtract 13 is 6. So now here we're left with a one-step equation that's only got the a variable. So here we can solve for the price of an adult ticket to go on the boat. So 3a means 3 multiplied by a. The inverse, the opposite of multiplying by 3 would be to divide by 3. Remember, when we're solving, we're working on isolating that variable. So we have a equals, we have to do the same to both sides. 6 divided by 3 is 2. So the price of an adult is £2. Now we can use that price of an adult to work out the price of a child. So we can substitute this value back into one of these equations and then solve it for C. So I'm going to use this equation here. So I'm going to use the Jones family equation. So 4a add c equals 9.5. We know that a is 2, so 4 multiplied by 2 add c is 9.5. Well, that's 8 add c is 9.5. Remember, we're trying to find out the cost of a child, so we're solving for c. So we want to isolate the variable c. We want it to be c equals. So we need to eliminate this 8 on the left-hand side. The opposite of adding 8, because that's a positive 8, would be to subtract 8. So when I subtract 8 on the left-hand side, I'm left with the variable c. When I subtract 8 on the right-hand side, I'm left with 1.5. So the cost of a child is £1.50. Now, we haven't finished there. We need to find out how much the Lee family pay. Okay, that's what we're aiming for down here. So we know the cost of an adult now, and we know the cost of a child. So for the Lee family, they tell us that they have 3 adults plus 2 children. So 3 adults. So the adults are £2, and then 2 children. The children are £1.50. So 3 times 2 is 6. 2 times £1.50, so 1.5 is 3. 6 plus 3 is 9. So the Lee family pays £9 in total to go on the boat. Question 12a. Circle the equation of a line parallel to the line y equals 4x add 5. So if lines are parallel, they have the same gradient. Okay, and when we're working in the form y equals mx plus c, m is your gradient. So the gradient of this line is 4. So we need to circle the equation of a line that also has a gradient of 4. So this equation has a gradient of -1/4. We're not going to include that one. This equation has a gradient of 4 because the m value is 4. So we're going to circle that one, but let's check the others just to be safe. Well, that's got a gradient of -4. That's got a gradient of a +1/4. Now this one is a little bit trickier. We need it to be y equals mx plus c. So I would have to divide by 4 to isolate that y. So when I divide by 4, that's going to be x over 4. So that's going to have a gradient of 1/4. So it's definitely this one. Part B, the gradient of the line which passes through, so we're working with the gradients, the gradient of the line which passes through the points A3 and 2A9 is 3/4. Find the value of A. Okay, so when we're working with the gradient, we do the change in y, so y2 subtract y1, divided by the change in x, so x2 subtract x1. So this is our x1, y1, and this is our x2, y2. So they should equal 3/4. So let's substitute in what we know for now. So y2 is 9. So that would be 9 subtract y1, which is 3. And then on the bottom, x2 is 2a, subtract x1, which is a. So 2a subtract a. Let's simplify this to get an expression for the gradient of this line. So 9 subtract 3 is 6. 2a subtract a is a. So 6 over a is the gradient, but they tell us that that should equal 3/4. Okay, so now we need to look at what's happening here. I need to find out what the a value is. Now working with fractions makes this a little bit simpler because we can see if these fractions are equivalent, if they've been scaled up or scaled down. Now looking at this 3/4, I can see that 3's been scaled up by multiplying by 2. So the same thing should happen to the bottom of the fraction. So when I multiply 4 by 2, I get 8. So a must equal 8. 13a, find the next term of the following Fibonacci type sequence. So we've got a sequence here, 0, 2, 2, 4, 6, and it wants the next term. Now the important thing to note here is it tells us it's a Fibonacci type sequence. So it's one of the special sequences that we need to know about. So to generate a Fibonacci type sequence, you add the previous 2 terms together to get the next term. So 0 plus 2 gives us 2. 2 plus 2 gives us 4, 2 plus 4 gives us 6. So to get this term, we need to do 4 plus 6. So that next term is 10. Okay, part 2. Here are the first 4 terms of a sequence. So we have root 3, 1, 1 over root 3, 1/3, and then we've got 2 terms missing. It wants us to find the 6th term of this sequence, and it wants us to simplify our answer. So we've got term 1, 2, 3, 4. We need term 5 and term 6. So we need to find the ratio between these terms. So the ratio to get from one term to the next. So to do this, okay, I'm going to take this term, I'm going to divide it by that first term, or the term before it. So the ratio is 1 over root 3. So what we've done is if we multiply each term by 1 over root 3, it will generate the next term. So let's check this. 1 times 1 over root 3 becomes 1 over root 3. 1 over root 3 times 1 over root 3 becomes 1 over root 9, which is 3. So we know that that ratio works. So I'm going to multiply 1 over 3 by 1 over root 3, this ratio. So that becomes 1 over 3 root 3. So 1 over 3 root 3 is my fifth term. I now need to multiply 1 over 3 root 3 by 1 over root 3, which becomes 1 over 3 times root 9. Root 9 is 3, so that becomes 1 over 9. So the sixth term is 1 over 9. Okay, part B, find the nth term of the following sequence. So when we're finding the nth term of a sequence, the first thing we need to do is find the difference between the terms. Okay, we want that common difference to get from one term to the next. So from -3 to 0, we add 3. 0 to 5, we add 5. 5 to 12, we add 7. 12 to 21, we add 9. So that first difference isn't the same. So we need to continue now and find the second difference. So that's the difference of the differences. So from 2 to 3, we add 2. 5 to 7, we add 2. 7 to 9, we add 2. So the second difference is 2. So this is a quadratic sequence because the second difference is the same. So for a quadratic sequence, to find our n squared term, we half the second difference. Half of the second difference is 2. So we're starting with n squared. So what we need to do now is compare this sequence with the sequence of squared numbers. So 1 squared would be 1, 2 squared would be 4, 3 squared would be 9, 4 squared would be 16, 5 squared would be 25. Okay, so first term, second term, third term, fourth term, fifth term. Now I'm going to see what's happened to get from the square numbers sequence to the sequence, the original sequence. So what do I need to do to make this into this? Well, to get from 1 to -3, we've subtracted 4. To get from 4 to 0, we've subtracted 4. From 9 to 5, we've subtracted 4. 16 to 12, we've subtracted 4, and 25 to 21, we've subtracted 4. So we've subtracted 4 every time, so I can simply write that the nth term of this sequence is n squared subtract 4. If I wasn't doing the same thing to get from the squared number sequence to the sequence that we're dealing with, if it was a different number each time, there'd be additional steps. But for this one, the answer is n squared subtract 4. Question 14a. So we've got a coordinate grid and we've got the shape A plotted on that coordinate grid. Draw the enlargement of rectangle A with a scale factor of 1/3 and a centre 0, 0. So we're going to draw an enlargement of that shape. The scale factor is 1/3. So even though it says enlargement, I know that the size of that shape is going to reduce because the scale factor is less than 1. It's a fraction. But we're going to reduce it and from a centre 0, 0. So the centre 0, 0 is here. So to do this, I need to take each point individually to start off with and plot its journey from that centre of enlargement. So if I'm going to this point here, so I've gone to the right 1, 2, 3 places, and then I've gone up 1, 2, 3, 4, 5, 6. So 3 across, 6 up. Well, I'm working with a scale factor of 1/3 here. It's a positive third, so I don't need to change direction or anything, but I do need to reduce that journey. So I need to divide that journey by 3. So instead of 3 across, it's only going to go 1 across, and instead of 6 up, it's only going to go 2 up because 6 divided by 3 is 2. So for this point here, its new position is 1 across, 2 up. So its new position is there. Okay, you can do this for each individual point. So for example, if I go to this point, it's gone 3 across, but then it's gone 9 up. So it would go 1 across, and then 9 divided by 3 is 3 up, which would be here. Or you could recognise that if it's a scale factor of third, every distance is getting divided by 3. So every side length of that shape's also going to get divided by 3. So this is a side length of 3. 3 divided by 3 is 1. So it's become a side length of 1 here. This is a side length of 1, 2, 3, 4, 5, 6. 6 divided by 3 is 2. So actually, we can redraw the rectangle once we've got a couple of points plotted quite accurately. But I'm just going to shade it in to make it nice and clear to the examiner. 14b. So triangle P, so this triangle here is reflected in the line y equals x, and the image is triangle Q. Now we can't see that on the diagram yet, but it's telling us that that's what's going to happen. Then it says triangle Q, so this one that would have been drawn here, is reflected in the line y equals negative x, and the image is triangle R. Describe a single transformation that maps P to R. So P to this shape R that we would end up with. So we're just going to carry out each of these transformations in turn, see where R ends up, and then take it from there. So the first one is triangle P is reflected in the line y equals x. So the line y equals x is a diagonal line through 0, and when y is 1, x is 1. When y is 2, x is 2. So we need to make sure we plot that accordingly. 6, 6. I'm going to do it from 6, 6 to minus 6, minus 6. You only need 2 points to plot a straight line. So I'm just going to make sure I do that accurately. So that's my line y equals x. And I'm going to reflect P over that line. So that point is invariant, it's on the line, so it's not going to move. This point is 1, 2 away from the line, but we're dealing with a diagonal line, so we need to then go at 90 degrees from the line, but the same distance, so 1, 2 away. This point here is, oh, I need to continue my line. There we go. So this point here is 1, 2, 3, 4, 5, 6. So 90 degrees, 1, 2, 3, 4, 5, 6. So that is that part of my triangle. Just be careful, so make sure this point is going to stay the same. So I can join those points up, but you might, if it's a more that didn't go very well. If it's a more complex shape, you may want to plot each point individually. Anyway, so this is image triangle Q. So let's label that as Q. So the next thing is that Q is reflected in the line y equals minus x. Well, if this is the line y equals positive x, the line y equals minus x is going to go in the other direction, because when y is 1, x is minus 2. So we've got the opposite. When x is 2, y is minus 2. So let's do 2 minus 2. Minus 2, 2. Remember, we need 2 points to draw a straight line. Draw that line through. So Q is reflected in the line y equals minus x to get R. So we're dealing with this line now. We're dealing with this shape Q. So we're going to start with this point. It's 1, 2, 3, 4, 5, 6 away from the line. Make a right angle. 1, 2, 3, 4, 5, 6. This one. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. I'm doing each point this time because there's quite a big distance between them and I really don't want to get it wrong. So here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good. When it's close together like that first one that we did, I'm okay doing it a few points and then making it join up. When it's a bit further away, I want to be accurate. So this image is triangle R. So now it wants us to describe a single transformation that maps triangle P to R. So if we were to just go from P to R straight away, what has happened? Well, the shape has changed position, but it's also changed orientation. So straight away that we know that this is a rotation. Okay, so it's turned. P has turned. Okay, and we're going to say it's a rotation 180 degrees because P has turned this way and then gone completely upside down. But we now need to identify that centre of rotation. So to identify the centre of rotation, we're going to map corresponding corners of P and R together. So this corner and this corner are corresponding. So let's join those up. This top corner and this corner are corresponding. So let's join those up. And then this corner and this corner are corresponding. So let's join those up. And we're going to look at where all those lines meet. So they all meet here at the origin. So we can say that it's been rotated 180 degrees around the centre, 0, 0. Question 15. A small tank is a cuboid. It has a square base of side 20 centimetres. The tank contains some liquid, but it's not full. So this is our cuboid. We've got a diagram of it here. We've got our square base that has sides 20 centimetres. And we have the shaded part that is some liquid, but the tank is not full. The diagram's not drawn to scale, so we can't measure anything directly from the diagram either. More of the same type of liquid is added to the tank. The total mass of the liquid in the tank is now 5,400 grams. The depth of the liquid has increased by 50%, and the density of the liquid is 0.9 grams per centimetres cubed. Calculate the original depth of the liquid, show all your working out. So we're starting with some liquid. We're adding some more, and when we add some more liquid, we get this mass and this density value. So I'm going to use the mass and density value to work out the volume, okay? Because the volume will tell me how much liquid there is after the depth has been increased by 50%. So let's start with that. So we're working with the volume, so we need to remember that density, mass and volume have a proportional relationship. It's not the best triangle in the world, I apologise. But volume can be calculated by doing mass divided by density. So we have a mass of 5,400 grams and a density of 0.9 grams per centimetres cubed. Now we know from previous videos that if I can avoid working with decimals on a non-calculator paper, I'm going to. So I'm going to multiply 0.9 by 10 to get 9, because working with a whole number, working with an integer is easier. But because I'm dividing, I have to do the same to the other side. Otherwise, I'm not going to get the correct answer. So now to find the volume, I'm working out 54,000 divided by 9. So I'm just going to use bus stop method. You can use whichever method works for you. 9's into 54. 9, 18, 27, 36, 45, 54. 1, 2, 3, 4, 5, 6. There's no remainder, so we need to carry these zeros up. So the volume after the additional liquid has been added is 6,000 centimetres cubed. Okay, so I'm going to now use the volume to find out the new depth. Okay, because I know that the new depth has increased by 50%. And to find the volume, I would do the area of the base, so area of the cross section of this shape, and then I would multiply it by that height, which is our depth of our water. So I'm going to find the area of the base. So area of base is 20 times 20, which is 400 centimetres cubed. So the area of the base would have then been multiplied by another value, which is the depth of the water. So if I divide our volume by the area of the base, that will tell me the depth of the water. Okay, so 6,000 divided by 400. Now I'm going to write this as a fraction, if I can't do that easily in my head, so that I can spot what these two values have in common. So I can divide the numerator and denominator both by 10. That leaves me with 600 divided by 40. I can now divide the numerator and denominator by 10 again, which leaves me with 60 divided by 4. 60 divided by 4 is a lot easier for me to work with. 60 divided by 4 is 15. So this is the new depth, guys, don't forget. So after this, more of the same type of liquid has been added. The new depth is 15 centimetres. We've been told that the depth increased by 15%. So this new depth is 150% of the original depth. Okay, so I'm going to work with one of those little proportion tables that I like to work with just to organise my thoughts and my working. So 15 centimetres, so we're dealing with centimetres and percent. So that 15 centimetres is 150% of the original. I want to find out what the original is, so I'm aiming to get to what 100% is. There's a couple of ways you can do this. Do this whichever way works for you. But I'm going to divide by 15 to get 10%. Okay, 115 divided by 15 is 10. 15 divided by 15 is 1. And then to go from 10% to 100%, I'm going to multiply by 10. So 1 multiplied by 10 is 10. So the original depth was 10 centimetres. Question 16a, write 13 to the power of negative 2 multiplied by 13 to the power of 7 as a single power of 13. So we're working with indices now, laws of indices, and because this is a multiplication, we're working with the law of multiplication. And the law of multiplication says that if the base number is the same and we are multiplying, we can simply add the powers. The base number here is 13 and we are multiplying, so 13 to the power of negative 2 multiplied by 13 to the power of 7 is the same as 13 to the power of negative 2 plus 7, which is 13 to the power of 5. A single power of 13 means we don't see 13 repeated. Part B, calculate the value of 8 to the power of negative 1 to the power of a third. Okay, so this is the power of a power rule. Still on indices, guys. So the rule here is that if we've got brackets, like we have, we can multiply the powers. So 8 to the power of minus 1 to the power then of a third is going to be 8 to the power of minus 1 multiplied by a third, which is 8 to the power of minus a third. However, we need a value, so we don't want to have that power there. We're evaluating, we're calculating what 8 to the power of negative a third is. So because we have a negative power, to eliminate that negative, we're going to write the reciprocal of 8. The reciprocal of 8 is 1 over 8. And that then makes the power positive. So by writing it as a reciprocal, we've negated that negative. Now I need to raise 1/8 to the power of a third. Well, when we're dealing with fractional powers, the bottom of the power, the bottom of the fraction is the root, and the top is the power. So we're going to start on the bottom. We're going to take the cube root of both parts of this fraction. So the cube root of 1 over the cube root of 8. Well, the cube root of 1 is 1, the cube root of 8 is 2, so that gets us to a half. And then we would then raise them to the power of 1, but anything to the power of 1 is just itself, so we're going to leave our answer there nice and clearly as a half. Part C, 3 to the power of 5 over a equals b root 3, where a and b are integers, so a and b are whole numbers. Find the value of a and the value of b. So we're going to be working with our indices knowledge and some surds knowledge here as well, guys. So remember what I said up here, when we had a power of a third, we cube rooted. So here we've ended up with a square root on the other side, the square root of 3. So that tells me that the bottom of the fraction must indicate that we are square rooting, okay, because the bottom is the root. So that a instantly must be a 2. So we're dealing with 3 to the power of 5 over 2 at the moment. So we know our a value. Now that we know that, we can recognise what would happen here. So the 2 would make us square root the 3. And then the 5, we would raise it to the power of 5. So we'd have root 3 to the power of 5. Now remember, to the power of 5 means multiplying it by itself 5 times. So it would be root 3 multiplied by root 3, multiplied by root 3, multiplied by root 3, multiplied by root 3. So let's simplify this a little bit more and see if it gets us any closer to finding that value of b that would be the coefficient of our root 3. Okay, so root 3 times root 3 gives us root 9. Root 3 times root 3 here gives us root 9. And then we've got that root 3 on the end. Well, root 9, the square root of 9 is 3. So that's 3 times root 3. 3 times 3 is 9. So we end up with 9 root 3. 9 is an integer. So that tells me that b must also be 9. Question 17a. Gracie has collected data about the heights of 30 giant sunflowers and the table shows her results. So we've got height and we've got continuous data here. So it's grouped data. So we've got these ranges of the heights and then the frequency of giant sunflowers whose height falls within that range. So Gracie attempts to draw a cumulative frequency diagram. So this is Gracie's attempt. Make 2 different criticisms of Gracie's diagram. So first of all, a cumulative frequency diagram should be a smooth curve. Gracie's joined all of her points up with a straight line. So I'm going to write it should be a smooth curve. The next point to note is that we should plot points on a cumulative frequency diagram using the end point of the range. So when I plot this point on the graph, I would plot at 3.5 on the horizontal height axis and then 5 on the frequency for the height. So if I go to 3.5, what we can see has happened here is Gracie's plotted the midpoint between 3 and 3.5, not the end point. And we use the end point for cumulative frequency. So I'm going to simply write points should be plotted using the endpoint of the range, not the midpoint. There we go. 17b. Gracie also collects data about the amount of money each of a group of 40 gardeners spent on their gardens during the months of April and May. And the table shows the data for April. So we've got a different set of data here, guys. The first part asks us to draw a histogram to represent the data for April. Okay, so we're going to represent this data in a histogram. Now, when we're working with a histogram, we're working with frequency density. Okay, so we need to calculate that frequency density. To do that, we do the frequency divided by the class width. So these are the classes, those ranges that we spoke about. So I'm going to do, for the frequency here, I'm going to do 6 divided by the class width. 0 to 30 is 30. 6 divided by 30 is 1/5, which as I know is 0.2. 9 divided by 30 to 40 is 10, so I know that's 0.9. 12 divided by 10, 1.2. 5 divided by 10, 0.5. 8 divided by 20, because the class width is 20 there. So 8 over 20 is 4 over 10, which is 0.4. So now I'm going to plot these decimal values that we've just calculated as our frequency density. Now a histogram has bars. There are no gaps between the bars because it's continuous data. but a histogram has bars. So we're going to draw those bars now. So the first bar is going to have a width of 0 to 30. So from 0 to 30 is going to be the width of our bar, and it's going to go up to 0.2 on our frequency density scale. So when we're going up, we need to figure out this scale here. So from 0 to 1, we've got 10 small squares. So each small square must be worth 0.1. So if I'm going to 0.2, that would be 0.1, 0.2. So that's where my first bar would end. Now it's not very clear with my pencil, so I'm just going to colour that in to make it a little bit clearer. Okay, the next data point we're plotting is a frequency density of 0.9, and it's the range from 30 to 40. So 0.9 would be here. There we go. And that's from 30 to 40. I'm only shading to make it clear because my pencil's not showing very clear on the grid, and I want to make it clear where my bars are, and I don't want to use pen just in case I make a mistake. Okay, next one. Frequency density, oh excuse me, of 1.2, and we're going from 40 to 50. So this is 1.1, 1.2. So we're going from 40 to 50, 1.2. Let's make it clear where that bar is. And then we're going 0.5 on frequency density and 50 to 60. So 50 to 60 to 0.5. And then 0.4 from 60 to 80. So 0.4 is here. We're going from 60 to 80. And then a little bit of shading just to try and make it clear where my bar is. Okay. The second part. The histogram below represents the data for May. For the frequency density, our histogram's already drawn. Calculate an estimate of how many more of the 40 gardeners spent 45 or less in May than that spent 45 or less in April. And you've got to show all your working out. So we're going to need our April graph here as well. So we need to keep that to hand. So we want to know an estimate of how many more of the 40 gardeners spent £45 or less in May than did the same in April. So let's figure out how many gardeners in April spent £45 or less to start off with. Okay, so we would have in April 6, 9, and then half, because we're only estimating here, remember. So the halfway point of 40 and 50 is 45. So we're going to estimate half. So 6 plus 9 plus half of those plus another 6 spent that £45 or less in April. So let's make a note of this being April so we don't get confused. 6 plus 9 plus 6, 15. So that's 20, it's not pounds, 21. So 21 gardeners spent £45 or less in April. It's just an estimate, remember, because we don't have exact values of what they spent. Now we need to figure out May, okay? So to figure out May, we find 45 on our histogram. So the amount here, 45 is that midpoint here. So let's section this off. So we are interested in this set of people here, this set of people here, and this set of people here. We're estimating, remember, so it doesn't have to be accurate. We're aiming for 45, and that is the midpoint of 40 and 50. So first thing we need to do is figure out how many people each of these sections are worth. Now, if you remember, when we worked out the frequency density in our original histogram to draw it, we did the frequency divided by the class width, okay? If we do the opposite now, if we multiply the frequency density and the class width together, it's going to get us back to our original number of gardeners. So you're basically finding the area of these rectangles. So for this section here, so let's label that A, B, and the little bit here we want is C. So for A, it's going to be 30 multiplied by, now figure out this scale. We've got the same scale here, from 0 to 1 is 10. So we've got 0.1, so that's 0.1, 0.2, 0.3, 0.4. So first of all, I'm going to do 30 times 0.4. Don't like to work with decimals on a non-calculator paper, so I'm going to multiply that by 10 to start off with. I'm multiplying so I don't do the same to the other side. 30 multiplied by 4 is 120, and then I'm going to reverse that multiply by 10. So I'm going to divide by 10. So A is worth 12 gardeners. Okay, let's figure out the area of B. So we're going to find out the number of gardeners in B. So 30 to 40 is 10, and then we're up at 1.5 here. So we're doing 10 times 1.5. Well, 10 times 1.5 is 15. So we have 12 gardeners and 15 gardeners so far. We need to find out how many would be in this small part C. So from 40 to 45 is 5, and then how far up have we gone? So that's 0.1, 2, 3, 4, 5, 6. So for C, we're doing 5 times 0.6. We're going to multiply this by 10 to make it 6. So we're doing 5 times 6. 5 times 6 is 30. Reverse that multiplication of 10. So that gives us 3. So for May, we have 12 plus 15 plus 3. So that's 27, that's 30. We want to know how many more. So the difference between 21 in April and 30 in May. So 30 subtract 21 is 9. So there's 9 more gardeners. Make that nice and clear, guys. Question 18a. So we've got a diagram at the top of the page there. It's not drawn to scale, so it's important to remember that we can't measure anything directly from that diagram. So the diagram shows a circle centre O. Points P, R and S. So P, R and S are on the circumference of the circle. Reflex angle POS equals 250 degrees, and that's marked on there for us. But then it continues to give us some more information. So the ratio of the angle OPR to the angle OSR, so OPR, OSR, is 2 to 3. Calculate the size of angle OPR, so we're aiming for this angle here, and you've got to show all of your working out. So first thing we're going to do is recognise that OPRS is a quadrilateral. Okay, that's a four-sided shape inside that circle. It's not a cyclic quadrilateral because all 4 points don't sit on the circumference, but it's still a quadrilateral. And we know that angles in a quadrilateral sum to 360 degrees. Okay, so that's an important thing to note. So I'm going to now start and see if I can figure out some of the other interior angles of that quadrilateral, because then that will help me find the angle OPR that I'm looking for. So I know straight away that I can find this angle here, so angle POS inside that quadrilateral. So here we've got a point, and around a point it's a full circle. So angles around a point sum to 360 degrees. So if I do 360 take away 250, that tells me that that interior angle of the quadrilateral here is 110 degrees. Okay, now I can use circle theorems to find this angle. Okay, and the rule I'm going to use is the angle at the centre is twice the angle at the circumference. Okay, so angle at the centre is twice the angle at the circumference. Okay, so that tells me that this reflex angle here of 250 is double this angle here. So 250 divided by 2 is 125, so this angle must be 125. Great. So we've worked out 2 of the 4 interior angles of that quadrilateral. We can't use this fact just yet, but we are going to use this ratio now to help us alongside that fact. So it tells us that the angle OPR is in the ratio with angle OSR of 2 to 3. So whatever those 2 angles should add up to is shared across this ratio. So if I take these 2 angles away from what the quadrilateral should sum to, then it leaves me with an amount I can share into this ratio. So 360 subtract 110, subtract 125. Okay, so that's 360 subtract 235, which is 125 degrees. So this ratio needs to be shared across those 125 degrees. So 2 to 3, so there's 2 plus 3, 5 parts in total in that ratio. 125 divided by 5. Well, 5 into 12 is 2, remainder 2. 5 into 25 is 5. So each part of that ratio is worth 25. So 2 times 25 means that's 50 degrees. And 3 times 25 means that's 75 degrees. Now the question asks us to find angle OPR, so this angle here, so it's this part of the ratio. So make it nice and clear for them. Angle OPR equals 50 degrees. Okay, 18b, we've got another diagram at the top, again not drawn to scale, so we can't measure anything directly from it. ABE is an isosceles triangle. So ABE is this large triangle here. And it's an isosceles triangle because these 2 sides are the same. AB is parallel to DC, so that ABCD is an isosceles trapezium. So ABCD in here is an isosceles trapezium. We have to prove that ABCD is always a cyclic quadrilateral and state any reasons that we use in our proof. Okay, so I'm going to start with the fact that this ABCD is an isosceles trapezium. Okay, because it's an isosceles trapezium, these sides are the same, which means these 2 angles must be the same. So angle A is equal to angle B, but then these 2 angles must also be the same. So angle C is equal to angle D. Okay. Now we're going to recognise the fact that AB and CD are parallel. So AB and CD are parallel. So because these lines are parallel, A plus D must be 180 degrees because they are co-interior. And also B plus C must be 180 degrees because they are co-interior. I best put angles as well just to be safe. There we go. Okay, therefore, because A equals B, A plus C equals 180 degrees. So A and C are opposite angles. And then B and D must equal 180 degrees because C is equal to D. So B plus D, opposite angles. So we're now going to state the rule that opposite angles in a cyclic quadrilateral sum to 180 degrees. So we've proved that it's always a cyclic quadrilateral because of these properties here. Question 19. You are given that y is inversely proportional to x squared when x equals 4, y equals 3. So part A wants us to find a formula for y in terms of x. So we're going to use the information it's given us in the question. Y is inversely proportional to x squared. So y is inversely proportional to x squared. So this then becomes a y equals k over x squared proportion formula. So that's the general form for it. I'm going to use the information they've given me, the two corresponding values. So when x equals 4, y equals 3. So I can use those to find k, this constant of proportionality. So if y is 3, substituting these in, and x is 4. Don't forget to square it here, guys. That's a common mistake that people make in the exams. They forget that it's x squared. So 3 equals k over 16. So k must be 3 times 16, which is 48. So now I'm going to rewrite this general form here, but with the k value included. So y equals 48 over x squared, and that's my formula for y in terms of x. Okay, part B and then part 1. Use your formula to find the value of y when x equals 8. So I've got this formula here, y equals 48 over x squared. When x equals 8, I want the value of y, so I'm going to substitute 8 into this equation. Remember that on the bottom there it's x squared, so I'm substituting in 8 squared. That gives me 48 over 64, and when I simplify that I get 3 over 4. So y equals 3 over 4, or 3/4, when x equals 8. Okay, B part 2. Use your formula to find the positive value of x when y equals 1200. The fact that it mentions a positive value makes me think, oh, maybe I'm going to get two values here. And then that's prompting the thought, well, if I'm going to get two solutions to my equation when I substitute something in, then that potentially means I'm going to be working with a quadratic. So if I see a quadratic appear in my working, I'm going to be quite happy because it means I'm on the right track. So we're working when y equals 1200. So we're going to use this general form again, but we're substituting in y equals 1200. So 1200 equals 48 over x squared. Now we're trying to find the x value. So first thing I'm going to do is I'm going to multiply by x squared. So 1200 x squared equals, and then I'm going to do the same on this side, 48. Okay, now I'm going to divide by 1200 because I'm aiming to get x. I'm aiming to isolate x. So divide by 1200, so x squared equals 48 divided by 1200. Now when I simplify that, x squared becomes 1 over 25. Okay, I did quick maths then, but you could go divide by 2 until you get to the point where you're at your simplest form. But I wanted it to be here because that looks nicer for me to work with, because I'm dealing with an x squared. So to isolate x and get the value, the next step is going to be to square root, and I can square root both of these numbers nice and easily. Potentially I couldn't square those ones nice and easily. I'd have to be simplifying surds, and as I'm okay with that because surds is one of my favourite topics, this is just going to make my life easier in the exam time-wise. So x is equal to plus or minus, remember, whenever we square root, there is a positive and a negative value to that. So it's plus or minus the square root of 1 over 25, which is plus or minus square root of 1 is 1, square root of 25 is 5. We want the positive value, so we're just going to tell them x equals 1 over 5. Question 20, write 3.21 recurring as a fraction. Give your answer as a mixed number in its simplest form. So this is recurring decimals to fractions. So I'm going to start by just saying that x is equal to this value, 3.21 recurring. Now note that the recurring symbol is above the 2 and the 1, so it means that it's the 2 and the 1 that repeats in that pattern. Okay? Now I'm going to make a multiple of x. So I'm going to scale it up to make a multiple of that. I'm aiming to have the same thing matching after the decimal point. Okay, so if I was to multiply this by 10, everything would shift across one place to the left. It would become 32.1212, Well, that won't match exactly here. So if I show you that, look. So 32.12121212, okay? My decimal point afterwards doesn't match. If I was to do 100x, so let's get rid of that one, everything shifts across 2 places to the left, so that becomes 321.212121. And what you'll notice here is after the decimal point matches exactly, and obviously this one would continue. So when you're finding your multiples of x, that's what you're aiming for. So you might start with 10x, but if it doesn't match exactly what's repeating after the decimal point, you can't use those multiples to solve this problem. So now I'm working with 100x and x. So I'm going to do 100x subtract x. So 100 subtract 1 is 99. So I have 99x. And then 321.21 recurring, subtract 3.21 recurring. Well, the 0.21 recurrings are going to cancel out. And then I'm doing 321 take away 3. Well, 321 take away 3 is 318. Now I'm going to divide by 99. So x equals 318 over 99. And what I'm going to do then is I'm going to see if I can simplify. Now I can divide numerator and denominator by 3. 99 is in the 3 times tables. And I know 318 is because 3 plus 1 is 4 plus 8 is 12. And that's in the 3 times tables. So when I divide them by 3, I get 106 over 33. But now I'm not finished. I need it in its simplest form as a mixed number. So I need to see how many 33s go into 106. So 33, 66, 99. So that's 3 of them. And the remainder to get from 99 to 106 is 7. So that's 7 over 33. And that's my answer. Question 21. In this question, all lengths are in centimetres, so that's important to know. We're working in centimetres. We've got a diagram here, a rectangle. We've got one of the side lengths labelled, and the diagram's not drawn to scale. Again, important, we can't just measure anything from a diagram. So, the length of the rectangle is root 5 add 3. They've got that on the diagram for us. The perimeter of the rectangle is 8 root 5 subtract 2. So the sum of all of the sides is 8 root 5 subtract 2. Calculate the exact area of this rectangle. So the word exact simply means that we're going to be dealing with something, or one of our answers written in third form. Okay, so it keeps it nice and exact. We don't have lots of messy decimals trailing on the end. So we're aiming for the area. So for the area, we need to do length multiplied by width. We know the length of the rectangle. We don't know the width. However, we know the perimeter. And to find the perimeter, we would do 2 lots of the width. So it would be so the perimeter would be 2 times the width plus 2 times the length. Well, the length is root 5 plus 3. Well, if the total of those, the perimeter is 8 root 5 subtract 2, then if I subtract this, the 2 lengths, it'll tell me what the 2 widths are worth. So let's do that. So 8 root 5 subtract 2, subtract 2 root 5, oh I can't write, plus 3. Okay. So this is the important thing now. We're going to expand that bracket and we're going to be really careful with our signs. So 8 root 5 subtract 2. So negative 2 times by root 5, so that's the first bit here, so that's negative 2 root 5. Negative 2 times by positive 3 is negative 6. Really be careful with your signs there, guys. So now we're going to collect like terms. So we have 8 root 5 subtract 2 root 5. Remember, we can add and subtract surds exactly the same way as we collect like terms with algebraic variables, as long as the surd matches. They're both root 5, so we've got 8 of them, subtract 2 of them. So we have 6 root 5 in total. And then we're going to deal with negative 2, subtract another 6. So it's getting more negative. So that becomes negative 8. So this is our 2 widths. Well, we only need 1 width to find the area because we do width times length. So I'm going to divide this by 2. So this becomes 3 root 5 subtract 4 because 6 root 5 divided by 2 is 3 root 5. Negative 8 divided by 2 is negative 4. So this is our width. So now we can calculate the exact area by doing the length times the width. So area equals length times width. So our length is root 5 plus 3. Our width is 3 root 5, subtract 4. And we're going to expand these brackets. So root 5 times 3 root 5 becomes 3 root 25. Root 5 times negative 4 becomes negative 4 root 5. 3 times 3 root 5 becomes positive 9 root 5. And 3 times negative 4 becomes negative 12. Now we're going to simplify this a little bit further. So 3 times root 25. Well, root 25 is 5, so that's 3 times 5, which is 15. Negative 4 root 5 plus 9 root 5. So we're collecting like terms again here, guys. Negative 4 root 5 plus 9 root 5. So negative 4 of them, we're adding 9. So we're going to get plus 5 root 5 here. And then we've got that negative 12 on the end. I'm going to simplify a little bit further because I can collect like terms with these constant variables here. So I've got 15 subtract 12, which is 3, plus that 5 root 5. So that's our area in exact form. Measurements are in centimetres, so I'm going to pop centimetres squared there. Question 22. So we've got a diagram at the top there. It's not drawn to scale, so obviously we need to remember we can't measure anything directly from it. And then we've got some information in the question. So O to A equals A. So this is a vectors question. O to A equals A. So we're travelling in the direction from O to A, and we're going to label that as A. O to B. So O to B is B. So that whole journey from O to B in the direction of the arrow is positive B. C is the point on AB such that AC to AB is 1 to 4. Okay, so AC to AB is 1 to 4. So the ratio of AC to that whole length, AB, is 1 to 4. So A to C is 1/4 of AB. So we just need to remember that fact. D is the midpoint of OB. So D is halfway across OB. Well, if the whole of OB is B, then O to D must be a half B, and then D to B must be a half B. So I'm just labelling things on the diagram that might help me a little bit later. So they want us to find DC in terms of A to B. So we want to go from D to C. So we've got to follow the journey of D to C. Wonderful. So if I want to go from D to C, I'm going to go D to O. Doesn't matter which way. You could have gone that way if you wanted, but I'm going to go this way. I've got more information labelled on my diagram to go this way around than I have this way. There's a big gap there. I could probably work with it and figure it out, but also I've got this information already, so I'm going to use it. So I'm going to go from D to C. I'm going to go D to O, O to A, and then A to C. Okay, what do I already know? D to O. It's going in the opposite direction to the arrow, so it's the negative a half B. O to A is A, so that would be plus A. And then A to C is 1/4 of A to B. Now, the only thing I don't know in this to simplify for DC is A to B. So let's plot that journey A to B. So if I'm going from A to B, let's go A to O, A to O, and then O to B, because I know information about that journey. So A to O is going in the opposite direction of the arrow, so that would be negative A, and then O to B is going in the correct direction, the same direction, so that would be positive B. So A to B is negative A plus B. So let's pop that in here. So DC is negative a half B plus A plus 1/4 of AB, which is negative A plus B. So let's give us something to work with here. So negative a half B plus A minus 1/4 A plus 1/4 B. So now we're going to collect like terms to get DC in terms of A and B. So we have our A's here. So we've got A, so a whole one subtract a quarter. So we've got a whole one subtract a quarter. So we're going to have 3/4 A left. When we're dealing with our B's, we've got minus a half B plus a quarter B. Okay, so minus a half B plus a quarter B. Well, we'll start with minus half, which is minus 2/4. So minus 2/4 plus a quarter is going to be minus 1/4. So that's minus 1/4 B. And then I'm going to simplify this in its simplest form. So I'm going to factorise. I'm going to pull out a factor of a quarter, which would leave me with 3A subtract B inside. Question 23. So we've got a graph at the top of the page there. The diagram shows a velocity time graph for the first 10 minutes of a cyclist's journey. The velocity is given in meters per minute and the time is given in minutes. So velocity in meters per minute, time in minutes. How many minutes after the start of the journey did the cyclist first travel at a velocity of 9 kilometers per hour? Now, what I would do is I would read that information from the graph that they're given us nice and easily, but unfortunately, our graph is in meters per minute and they're asking us for kilometers per hour. So I'm going to have to convert that 9 kilometers per hour into meters per minute. Okay, so there are 1,000 meters in 1 kilometer and there are 60 minutes in 1 hour. So I've just popped my conversion comparison for meters and kilometers and minutes and hours there just to remind myself. So the first thing I'm going to do, I'm going to start with this 9 kilometers per hour. I'm going to times it by 1,000 because I want to convert it into meters because I want to be working with meters. So 9,000 meters. Okay, now I need to go from hours to minutes. So I'm going to divide by 60. So divide by 60. So 9,000 divided by 60. Well, 60 into 90 is 1. Remainder 30. 60 into 300 is 5. No remainder, so that's 150. So it's 150 meters per minute. All right, now I can read that information from my graph because it's in meters per minute. And I can read straight from my graph. So I'm going to find my pencil just in case I make a mistake. So I want to go to 150 meters per minute, guys. So up here, velocity meters per minute. Okay, and I'm going to draw a line. Now what you will notice is if you continue drawing that line, it will cut through 2 parts on the curve. Don't worry about that because it just wants to know how many minutes after the start the cyclist first travelled at a velocity of 9 kilometers per hour. So they did it more than once, but we're just interested in this first point here, okay? That first point of intersection. And then I'm going to carry my line down and then I'm going to read across the scale. So from 7 to 8 is 5 squares, so it's 0.2 per square. So that's 7, that's 7.2. So it was 7.2 minutes after the start that they first travelled at a velocity of 9 kilometers per hour. Question 24a. Solve the equation 5x squared subtract 8x subtract 1 equals 0. Then it asks that we give our answer in this form where m and n are integers. So that's a big clue as to how I'm going to solve this. Instinctively, usually I try and factorise quadratics to solve them because I find that a simpler method. However, because it wants my answer in this form, this is an exact form that involves some kind of surd, I'm not going to get that from factorising. I'm actually not going to be able to factorise and get integer values. So this tells me I either need to complete the square or use the quadratic formula, because both of those will give me exact forms, okay, for this answer. I'm going to go with the quadratic formula. It's on the formula sheet at the front of the exam paper as well, guys, but you could go with whichever method you are most comfortable with. So the quadratic formula is x equals minus b plus or minus the square root of b squared minus 4ac, and that is all over 2a. So when I look at this equation here in the form ax squared plus bx plus c, well, a is 5, b is minus a, and c is minus 1. So they're the a, b, and c values that we're going to substitute into our quadratic formula. So minus b, so minus minus a, everyone makes a mistake with that, guys, so be really careful. It's the opposite sign to what b is, that's saying. So it's the negative b. So if b is negative 8, then it's going to be positive when I write it inside here. And then negative 8 squared minus 4 times a times c, all square rooted, all over 2 times a, which is 2 times 5. So we're going to simplify this a little bit. So we've got 8 plus or minus, negative 8 squared is 64. And then we're subtracting 4 times 5, which is 20. 20 times minus 1, which is minus 20. That's still inside our square root sign, guys. It's really easy to make a mistake with this, so it's best to do it step by step like I am, just to be careful and accurate with your calculations. 2 times 5 on the denominator is 10. So we're going to simplify even further. So we've got 8 plus or minus the square root of 64 minus minus 20, so that becomes plus 20 over 10. Which becomes 8 plus or minus the square root of 64 plus 20, which is 84 over 10. Now, I want to simplify this as much as possible. Now, I know that I can simplify the third root 84. So, root 84, that's the worst square root sign I've ever written, I do apologise, is the same as 4 times 21, which is 2 root 21. So we have 8 plus or minus 2 root 21 all over 10. Now I can simplify this further. I'm aiming for it to be over 5. And the reason why simplifying root 84 helps is I've now got 8, a coefficient of 2 and 10 that are all even numbers that can be divided by 2. And when I divide them all by 2, I'm going to get 5 on the bottom, which is what we're looking for. I couldn't divide them all by 2 if they weren't all integers, all even numbers and divisible by 2. So just be aware of that, guys. So 8 divided by 2 is 4, plus or minus 2 divided by 2 is 1. So root 21 all over 5, okay? So this is our final answer. M and N are both integers. Okay, part B, use factorisation to solve the following equation. So it's telling us we're going to factorise, but we need to rearrange and manipulate this a little bit because we want to factorise it. It needs to be in a better form than that. It needs to be a little bit less messy. So the first thing I'm going to do is I'm going to multiply both sides by x subtract 1 to eliminate this fraction on the left-hand side. So 4 equals 3 times x subtract 1 plus 2 times x subtract 1 over x. Now I'm going to multiply by x to eliminate this fraction. So I'm going to multiply by x. So this left-hand side is 4x. When I multiply this by x, I'm just going to write it as a coefficient in front of the bracket here. And then when I multiply the fraction by x, it eliminates the x on the denominator for me. Remembering that we had to multiply everything here, 3 and 2 over x by x minus 1. And here we had to multiply everything by the x that wasn't included in the fraction as well. That's a mistake that people tend to make. Now we're going to just simplify things a little bit. So 3x times x is 3x squared. 3x times negative 1 is negative 3x. 2 times x and then 2 times negative 1. So if I want to factorise this, I need a quadratic that's nice and simplified and is equal to 0. So I'm going to simplify the right-hand side first. So 3x squared minus 3x plus 2x. That leaves me with negative 1x minus 2. Minus 2, I don't know why I said plus 2. Apologies. Now I need it to be equal to 0. So I'm going to have to subtract that 4x. So that becomes 0. So 3x squared minus x subtract another 4x is minus 5x. Subtract 2. Now it's equal to 0. We're going to factorise. So because the coefficient of x squared is a prime number, I know the only way I can make x squared by expanding 3x squared by expanding brackets is 3x multiplied by x. And now I need two numbers that will multiply to give me negative 2 add to give me -5, but whichever number goes here is going to get tripled. It's going to get multiplied by 3, so I need to be careful with that. Well, there's only one pair of numbers that's going to make 2 when I multiply them, 1 and 2, okay? One of them needs to be negative because I want a -2 when I multiply them. So this is where I need to be careful. So I'm going to put my 2 there and my 1 here. I'm going to put a +1, I'm going to put a -2 because 3 times -2 is -6, +1 is -5. So I now have two numbers that multiply to give me -2, but when expanded, add to give me -5. So we're solving by factorising. So this is equal to 0. So we're going to make each bracket equal to 0 and we're going to solve for x. So we've got -1/3 there. And x equals 2 here. So there are two solutions. Question 25. The following probabilities are given for events A and B. So the probability of A is 0.3. The probability of A union B is 0.7. And the probability of A intersection B is 0.1. So in terms of set notation, A union B means it's anything that's in A or it's also in set B, okay? A intersection B is anything that's in A and in B, so anything that they've got in common. And part A says, by drawing a Venn diagram or otherwise, find the value of probability of B. I'm going to use a Venn diagram because I like diagrams to sort information. So I'm going to draw a Venn diagram and I'm going to say that that's set A and that's set B. So I'm going to start here, A intersection B. So that's the probability that an element is in set A and in set B. So that's the middle part of my Venn diagram there. So I'm going to fill that in, guys, okay? And then I'm going to use this piece of information. So it says that the probability that an element is in set A is 0.3. So the probability of it being in this circle A is 0.3. Well, I already have 0.1 taken care of, so if I subtract that, the rest of the A circle must be 0.2. Now I'm going to work with this piece of information here. So this is the probability of A union B, okay? So this is probability that it's in A or it's in B or it's in both, okay? So it's in A or it's in B, so that total probability should be 0.7. Well, I have two pieces of information already. So 0.7 subtract 0.2 subtract 0.1. So that's 0.7 subtract 0.3. So that is 0.4. Okay? So 0.4 is the bit that's missing there. Okay? At this point, I'm going to go back to the question. It wants the probability that something is in set B. So it's this probability here. Okay, it's the full circle. So the probability that we're in set B is 0.1 plus 0.4, which is 0.5. Okay, part B. Find the probability that it's in the set A complement intersection B complement. So that symbol there is the complement. So that means it's not in A. B complement means it's not in set B, and this set notation here is the union. So we're looking for the probability that it's not in set A, or it's not in set B, or it's not in both. So let's think about how that would look as a diagram. Okay, so I'm going to do a little bit of sketching here. So if this is our Venn diagram, we've got A and B. For it to not be in A, it would be everything that isn't included in the A circle. Okay? So that would be A complement. B complement is everything not in B. So it would be all of this information there. Okay? So this wants the probability that it's not in A or it's not in B. Okay, so we want to see what the overlap would be. Now, the only part that is not shaded in both of those things is that middle part of the diagram, okay? Because when it's not B, this is not included. When it's not A, this is not included. So the only part that's actually not included is that middle part, that intersection part, okay? So we need to take that intersection part away and it will tell us this probability. Now, probabilities add to 1. So probabilities add to 1, but if I take away that intersection of 0.1, then this probability must be 0.9, because the only thing that they don't have included in A complement and B complement that matches is that middle point, so we need to take it away from this whole probability.